Welcome to video 2. So in this video, we're going to talk about the second generalization or second rule of exponents, or second pattern you can discover. And this one I like to call power to a power. And for this particular pattern, what we're talking about is, let's say you have something like 4 to the third power taken to the second power. So we call it power to a power because it's an exponent taken to another exponent. And this has a pattern just like multiplying exponents had a pattern. So to discover that pattern, I'm going to show you what this looks like in expanded form. First of all, think about the inside. On the inside of the parentheses, we have 4 to the third power, which means we multiply the base number, 4, times itself 3 times. And that is what is being taken to the second power. Well, the second power tells me that I have 2 of these things multiplied by themselves. So what that looks like is this: 4 times 4 times 4 times another set of 4 times 4 times 4. And remember, I can write these parentheses right next to each other. It still means times. Well, if I want to simplify this back down into one exponent expression, really I just have 1, 2, 3, 4, 5, 6 4s all being multiplied together, which has the same value as 4 to the 6th power. Which means 4 to the third to the second is actually equivalent to 4 to the 6th. Kind of like in the last video, I want you to be thinking to yourself now, what pattern do you see that would help you simplify this expression into 4 to the 6th power without having to expand it? So I'm going to show you one more example, and I want you to have that thought in your head as you're watching this. What pattern do I observe? So I'm going to look at x's again, and let's say I have x to the 4th power to the 3rd power. So again, power to a power, x to the 4th to the 3rd. And so thinking about what this really means, it means inside those parentheses, I have x to the 4th power, which looks like this. 4 x's all multiplied by each other. On the outside of the parentheses, it tells me to take this stuff to the 3rd power, which means really I've got this 3 times. So I've got a second set of 4 x's multiplied, and I've got a third set of 4 x's multiplied. This is what x to the 4th power to the 3rd power looks like if you expand it all out. And as you can see, that's kind of a pain to write. It starts to get to be a lot of x's. If I had powers any higher than 4 and 3, it would really be a pain to write. So that's also why we want to be thinking about what pattern could we use so that maybe in the future we don't have to write everything out in expanded form. So if I look at this, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's all multiplied by each other, which is x to the 12th power. So what that tells me is x to the 4th power to the 3rd power is equal to or equivalent to x to the 12th power. So as I erase the board, I want you to think about what pattern do you observe? How could I get that x to the 12th power or that 4 to the 6th power without having to write out all of these things? Okay, so the 2 examples I showed you, which were 4 to the 3rd power to the 2nd power, which was equal to 4 to the 6th power, and x to the 4th power to the 3rd power, which was equal to x to the 12th power. So you may or may not have noticed that this power, I could have gotten the same thing by multiplying the 2 powers. Because multiplication means how many sets of something do you have, and here I've got 2 sets of 4 to the 5th, or of 4 to the 3rd, which gives me 4 to the 6th. And here I've got 3 sets of x to the 4th, which is 3 sets of 4 x's, which is 12 x's. So really the rule or the generalization for a power to a power is if you have a number raised to a power and then raised to another power, another power, you can keep the base and multiply the powers. So the way that this would work, just written kind of as a general rule, is if I have x to the m power to the n power, it's the same as x to the m times n. Now this seems simple. People tend to start getting these rules confused if you're just trying to memorize them. So if you ever forget that power to a power means you take x to the m times n, then really expand it out for yourself and you'll get the same result. So that is power to a power. One other thing I want to show you before I end this video and move on to the next one is that sometimes you have more than one thing in parentheses taken to a power. So let's say I have in parentheses x to the third power, y to the second power, to the third power. I want you to look at what this means in expanded form. What it means is inside parentheses, I have x times x times x times y, because that's x to the third, y to the second. And my outside power tells me I need all of this written 3 times. So I have x times x times x times y, and then again, x times x times x times y times y. And in the end, if I want to simplify this, I have to figure out how many x's do I have multiplied together. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, which would leave me with x to the 9th power. And then how many y's do I have multiplied together? So I've got 1, 2, 3, 4, 5, 6. So I have x to the 9th, y to the 6th. If you think about the power to a power rule we were just talking about, which says if you have a number raised to a power to another power, you can just multiply those and keep the base. Well, in this case, that would look like x to the third to the third. Well, 3 times 3, that's 9. So it's x to the 9th. Y to the second to the third? Well, I can just multiply these and I end up with y to the 6th power just by doing 2 times 3. All right, thanks.